We kindly invite you for this conference named as by Marina Flórez from the Western Autonomous University here in Colombia. And the presentation today is use of biomass for different applications to bioenergy. Good afternoon, you all. Thank you very much to the organizers for inviting me, especially Chancellor's Office from the Republic of Colombia, and Mr. Edgar Gonzalez for his kind invitation. I'm going to get out of a topic of other presentations, and I'm going to give you certain general aspects on how could we use biomass in the concept of biorefinery with a different application using bioenergy. In Colombia, we have several types of biomass. The first one is from the agricultural sector. Amongst those, we have several types of biomasses derived from the agricultural sector. They are named RAC, harvest agricultural waste, and agri-industrial waste. From the cattle breeding, from bovine, porcine waste, and urban and bird waste, and organic urban waste, cities, marketplaces, etc. In these biomasses, according to the Atlas of Biomasses that was built by the Unit of Mining Energy Planning in 2010, it was found that approximately in those agricultural sectors we had 72 million waste tons per year. In the cattle breeding sector, about 105 billion tons waste, and urban waste in percentages, we see that the agricultural waste covers 59.4%, agricultural waste 40.5%, and urban waste 0.1%. In Colombia, we are widening this atlas of biomasses. One is finished in Antioquia province, the other is in Valley projects in Bogota city. In the Cundinamarca and Boyacá provinces, they are making another atlas, another map of biomass generation, and in Santander province also. It is likely that in some years' time we're going to have a bigger consolidation of this waste, and we're going to have bigger, significant percentages. These are important amounts of waste generated by Colombia in a year. But what do we do? Well, mainly we've seen the application of this waste is in bioenergy, but because of the composition of these biomasses, this could have application in many other sectors, in fields of chemistry, in cosmetics, bioplastics, food, pharmaceuticals, and also in matters for several sectors: automotive, construction, in the sector of the aerospace activities, paper, packaging, etc. So it is important to understand what of those products we could give a value, and for that we would like to see this relationship. We see that in the basis of the pyramid we have the use of biomasses to produce energy, where we have the great applications of the use of biomass because of bigger volume that is possible to generate resources from it in the case of biofuels. But in the top of the pyramid there are other products that are also important, and they have very good markets and very promising markets. In the case of the use of biomass for the chemical industry, we see that from the waste generated in biodiesel production, which is the diesel is produced, and glycerol. We can produce diols by fermentation, and we see that this is a very big market, specifically to substitute ethylene glycol, which is fossil, and 1,3-propanediol. As you can see, these are markets around in 2021 estimates $21 million estimate market, and in ethylene glycol there's production of 20 metric tons production per year. Because of fermentation from the sugars obtained from the biocellulose, it is possible to obtain butylacrylate that has many applications as dispersing, surfactants, adhesives, paintings, with markets that are very significant, around $8 billion. If we summarize this sector, there are markets that are around 50 billion euros in the European Economic Community. In the case of butylacrylate, the biggest use is for pampers. Also, organic derives, malic and succinic acids. This could be used in making resins, preservatives, oils and fats, production of natural fibers. It could be used also in making foods and beverages. It has a world market around 60 billion tons a year, $130 billion with a growth of 4% a year in this world market. In polyamides obtained by fermentation from sugars, it is possible to obtain cables and other wires, and these have very promising potential markets compared to the biomass and other applications in the chemical fields, such as in the case of fertilizers and insecticides. Another field that is in continuous growth is bioplastics. In the world, 260 billion tons of plastics are produced a year, out of which bioplastics are scratching only 1% of this world consumption. These plastics are derived from starch because of fermentation. You can obtain several types of materials, PLA for example, which is polylactic acid, PHH, polyhydroxyalkaneate, and PHD. Out of those materials, 39% is biodegradable, and the rest, which is combined with fossil materials, this is considered non-biodegradable, but there's an important growth niche in this sector. Above all, because this has the advantage of being biodegradable, they are biocompatible. We know they could be synthesized from renewable sources, but they are 10 times more expensive from plastics originated with fossils. What is the future? To seek to have fermentations from low-cost materials as glycerol, raw glycerol, and hydrolyzed from cellulose and hemicellulose. Other sector that in this moment I see a very good projection is the use of cellulose, above all in the obtention of nanocellulose and nanofibers. This consists in submitting, in the case of nanocellulose, submitting cellulose, whether lignified or not, to strength of 550 bars in equipments as the one we see here. They are microfluidizers in order to have a matrix that is kind of a gelatin, and it is composed by microfibers. In case they have a length around microns or nanometers, and if these are disintegrated in chemical manners, you can obtain microfibers that have nanometers in diameter. Here, this is a micrograph where we can see the microfibers and nanocrystals of cellulose. What are the applications of this? This could be used as filtering method, and there are certain types of microcellulose that are bacterial, coming from Acetobacter, for example. It is important to characterize these fibers and apply several technologies of microscopy in order to characterize them and define what is the range. In this case, microscopy could be applied for atomic purposes or transmission in order to characterize this kind of fibers. Depending on the being fibers or crystals, there are many applications. For example, in the case of therapies for skin, to do grafts for substitution of artificial veins in food and in paper making. Amongst all, the most promising is the use of nanofibers as coating for paper. These are studies made in Aalto University in Finland, where they found where there is technological maturity compared to the volume of the use of this type of materials. It was noticed that the main application could be in coatings in fields of paper, as we can see in this chart. Most of the technologies is under demonstration, but we see that cellulose biomass is not only to generate power or energy. This is a limitless source of compounds from which we can obtain many materials to give them a value, and in that way use biomass under the concept of biorefinery. Thank you very much.